What if I told you there's a theoretical paper out there, a blueprint really, to break the entire internet? Today, we're diving into an astonishing idea, a master key to the whole digital world. Let's get right into it. Think about it for a second. From your bank account to your private messages, from all of crypto to top secret government files, pretty much all of modern digital security rests on a single belief. The belief that one specific type of math problem is just way too hard for any computer on Earth to solve in any reasonable amount of time. It's the very bedrock of our trusted, encrypted world. So what if that foundational idea is just wrong? What if that unsolvable problem could actually be solved instantly? Well, a recent theoretical paper proposes exactly that. It outlines a method that doesn't just crack the problem, it completely reframes it, suggesting we've been looking at the whole thing the wrong way all along. Now, to really understand the threat here, we first have to understand the lock. It's called elliptic curve cryptography, and the secret to its strength is a puzzle known as the elliptic curve discrete logarithm problem, or ECDLP for short. Just think of it as the most complex, unpickable digital lock ever invented. The whole system hinges on a really simple but brilliant trick. See, it's incredibly easy to take a starting point, let's call it P, and jump along a curve a secret number of times. We'll call that K. To land on an endpoint, Q. Super easy. But it's considered practically impossible to look at that starting point P and the ending point Q and figure out how many jumps, K, it took to get there. The world's best computers would take literally trillions of years to find K. This is what's called a one-way function, and it protects, well, everything. Okay, so now let's talk about the source material for this whole explainer, a paper that describes a hyperbolic oracle. It proposes a theoretical way to find that secret number K0 in trillions of years, but in a single computational step. It's basically a blueprint for a master key that could unlock every single one of those digital locks, all at the same time. And this slide, wow, this really shows you the sheer difference in the approach. Current attacks are kind of like trying to find one specific grain of sand on a massive beach by checking every single one. The hyperbolic oracle theory, on the other hand, suggests there's a secret map and a compass that takes you right to it. And just look at the time difference. It goes from an unimaginable number down to a single instant. So you're probably wondering, how on earth could this even be possible? Well, the genius of the paper isn't in solving the hard problem faster, it's in transforming the hard problem into a ridiculously easy one. It's about changing the very landscape of the puzzle itself. And this quote from the paper just nails the core idea. Instead of walking along the curve step by step, which is a problem of time and sequence, the oracle changes the math so you can see the curve as a map. Suddenly, the problem becomes one of space. You just have to find a coordinate. You're no longer counting steps, you're just reading a location. So, to navigate this new map, the paper proposes a specific tool, a little 64-bit data pocket it calls the symmetric hyperbolic domain compression protocol. Yeah, it sounds super complex, but let's just break it down with these analogies. Think of it like this. You've got a 32-bit compass to set your direction, a 16-bit tool to measure the distance you need to go, and then a final 16-bit check to make sure you've landed in the right neighborhood. And this tool works in a really simple 3-step lookup. First, the packets quaternion gives you the direction on this hidden map. Then, the DSM-SEM part tells you the distance. And finally, the halo bits just confirm you're at a valid spot. You put them all together, and boom, you've pinpointed the exact location of that secret number K. But this all begs a massive question, right? Where does this map even come from? I mean, how can something as wild and complex as an elliptic curve be turned into a simple coordinate grid? Well, the paper's answer is maybe the most profound part of its entire theory. The theory speculates that the structure of these cryptographic curves isn't random at all. Nope. Instead, it might be determined by a deep, hidden geometric pattern found in prime numbers. The very numbers we thought were the most random and unpredictable things in mathematics might actually be the source of a perfect, predictable order. And here's how it supposedly works. The oracle finds a specific type of prime number triplet. These 3 primes then act as the x, y, and z axes of our map. And once you have those axes defined, finding the secret becomes as simple as a direct data lookup. That's the mechanism behind that instantaneous O of 1 solution. In computer science, O of 1 means an operation that takes the same amount of time, no matter how big the problem is. It's the absolute holy grail of efficiency. So, okay, let's just step back for a minute and assume this theoretical oracle is real. What actually happens? What's the fallout? Well, the consequences aren't just bad. They represent a complete cascading failure of the digital world as we know it. I mean, this chart says it all, doesn't it? On one side, you have the time it currently takes to break these codes. That bar is so tall it represents more than the age of the known universe. And on the other side, you have the Hyperbolic Oracle, a bar so tiny you literally can't even see it. It represents a single moment in time. Phase 1 would be immediate. Every single system built directly on the elliptic curve problem would just shatter. All your secure messaging apps would be wide open for anyone to read. The private keys for cryptocurrencies like Bitcoin and Ethereum, completely exposed. Digital signatures proving your identity online would become absolutely meaningless.
But it wouldn't stop there, not by a long shot. The core mathematical insight here, turning a time problem into a space problem, would almost certainly apply to the other major pillars of cryptography. That means the RSA system, the one that protects most e-commerce and website connections, would probably be the next to fall. It would be a total domino effect.
And then we get to phase 3. This is an earthquake in the world of pure theory. This would challenge the very existence of one-way functions, this idea that some problems are easy to do but hard to undo. It would strongly suggest that P equals NP, which is only the most famous unsolved problem in all of computer science. It basically asks, if the answer to a problem is easy to check, is it also easy to find? If the answer is yes, that would totally rewrite our understanding of what computers can even do.
And all of this leaves us with one last truly fascinating question to think about. If a hidden geometric order in prime numbers really does govern our digital reality, then does that mean that mathematics isn't something we humans invent, but a fundamental structure of the universe that we are only just now beginning to discover and map? What else is out there hidden in plain sight?